Okay, folks, welcome to Chapter 2, Radical Functions. Now, nothing really new here because you've done radicals in Math 10C, right? You also did radicals in Math 20-1. You've done them before, but here in Math 30-1, here's what I want to do. I want to actually take the graph of these guys and I want to transform them. So in other words, I want to stretch them, I want to reflect them. I want to translate them by moving them up and down, left and right. Oh, way too cool. But remember, if you're looking at the definition of a radical function, remember, it's a function which contains a variable in the radicand. So the simplest form is y equals the square root of x. But remember, we're talking functions, so we actually can write it as f of x equals the square root of x as well. Now, here's the cool thing. Depending on what happens underneath here, it really helps to determine the outcome of the graph. What am I talking about? Well, let's start talking about looking at the simplest type of graph we've got. Y equals the square root of x. Look at this. I got a whole bunch of x values here. 0, 4, and 9. Square root of 0, of course, is 0. Square root of 4 is 2. Square root of 9 is, of course, 3. And I started it right here, you can see. Then I went to 4, 2, then 9, 3, and so on and so forth. But if you notice something very interesting, there's no graph out here, and there's no graph down here. Everything seems to be right now in the first quadrant. It all seems to be right here. Now, the question is why? Well, remember how I said it depends on what's underneath this radical sign. Think about it. Think of the restrictions on this. We cannot take a square root of a negative number. Now I see it. Think about this. I can't take a square root of the negative 1. There's no such thing. That's why there's no negatives. Also, once you take a square root of something, it can't be negative either. So there's no negatives in the y either. So it starts currently on the 0, 0, giving you kind of the general shape of this little arc like this, right? And it's going out in that direction positively. Aha. So let's rewind here for a second. Let's slow down. Let's start talking a little bit about domains and ranges. Domain then, like I said, this domain depends on what the starting point is. But how do you determine the starting point? The starting point is actually determined by the restriction of this radical. What's underneath here that tells you, oh, you can't go past this point? So probably the easiest way to look at it is looking underneath the radical. Whatever is underneath this radical here, in this case, x, just say, oh, x can't be negative, but it can equal to 0. So just say x has got to be greater than or equal to 0. Look at that. All my values of x are, in fact, greater than or equal to 0. That's how you determine the restriction. That's how you determine the domain. Now, range, best thing you can do, just do a quick graph. Range is there. But if you think about it as well, range also depends upon the starting point of the radical. So it's also dependent on what's underneath here as well. Fascinating. So in this particular question, the domain then has to be x has got to be greater than or equal to 0, and the range in this case has to be y greater than or equal to 0. Wow, is that ever interesting? Now, can we play around with this a little bit? Absolutely. Let's take a look at a couple of examples, and let's take a closer look at the restrictions. Oh, hey, look at that. Close look at the restrictions. Wow. Okay, so knowing the restriction of the graphs help us determine which values are permissible, and then eventually the domain and the range of the function. Let's look at this, and you'll see what I mean right away. Look, there's our radical. So what we have to do is we have to look at what's inside the radical. You know and I know inside the radical has to be greater or equal to 0. So what's inside the radical? X minus 4. All we have to do is solve for it. Oh, add 4 to both sides. X greater or equal to positive 4. So that means we'd start on the 4 right here, And you know the shape already is kind of gives you that kind of little arc looking thing. It's like somebody kicked a soccer ball or something. That's basically what it looks like. So the domain for this is x greater or equal to 4. Well, that wasn't so tough. How about this one here? Look at this guy. 2x plus 8 then. We'll do the same thing. Solve for what's underneath the radical. Tell me what the restriction. That 2x plus 8 better be greater than or equal to 0. Well, then ask yourself, what values of x make that greater or equal to 0? Well, solve for it. 2x greater or equal to negative 8. Divide by 2, divide by 2. X is greater or equal to negative 4. Interesting. So this guy starts a negative 4 right here, and there's that arc again. Ah, very interesting, very fascinating to see what happens with that. So this would be x greater or equal to negative 4 is your domain. Notice that the y's haven't changed, though. Notice the y's have not changed. Y's still tend to be greater than 0. Okay, that's not really important yet. We will make it important soon. Let's take a look at this guy now. This should be interesting. Look at C. C is a little strange because now everything's negative under here. But just remember, this guy has to be negative 2x minus 10 has to be greater than or equal to 0. Okay, solve it. Bring the 10 over. You got minus 2x. It's got to be greater or equal to 10. Divide by minus 2. Divide by minus 2. X, uh-oh. Uh-oh. Remember, when we're dividing by a negative, what happens to this inequality? That's right. It's got to be flipped. So this is negative 5. So your values of x have to actually be less than negative 5. So negative 5 is your starting point. Values less means that it's going to start arcing this way. Why? Because you want values less than negative 5. Values bigger than negative 5 aren't going to work. Case in point, don't believe me? Try a value bigger than negative 5. Try 0. You put 0 into here. Look, minus 2 times 0 is 0 minus 10. You got the square root of negative 10, and you know and I know you can't square root a negative. Interesting. So if you think about this then, this idea of this restriction also determines the shape of the graph, the way the graph is going to arc. Oh, is this ever cool? So x in this case is less than or equal to negative 5. Now, I do have a question though. I want to look at something called interval notation. Now, I don't know if you remember this from Math 20 or not, but interval notation uses square brackets and round brackets. Easiest way in the world to remember this. If it is a round bracket, that happens, for example, if you're talking about negative 5, that round bracket happens, you put a circle around it. That circle means not to include the number. So this would be something like this rewritten would be something like x is less than 5, telling you to start at 5, but don't include the number. The second you make it equal to is the second you put a solid bracket. So this would be like putting a dot then and saying, okay, we're going in that direction. Get it? So one's a circle, one's a dot. Dot, circle. And if you think about it, that arc, if you keep that arc going, it kind of looks like a circle, doesn't it? Aha! Open circle, solid dot. Big difference. Now, what does this mean in terms of domains and ranges? I want to talk about this for a second. Let's talk about domains and ranges. Let's go back to this first example. Let's talk about domains in interval notation. Okay, so we're talking interval notation. Think about this. This guy starts at 4 and continues on forever and ever and ever. Amen. So we're going to start at 4. That means that includes 4. We're going to put a hard bracket. But it goes on forever, which means it's going to go on to infinity. What kind of infinity? Positive infinity. It goes in the positive direction. So it's positive infinity. Can you ever get to infinity? Nope. Of course not. You'll never get to infinity. It's impossible. So you put a soft bracket to say that you're approaching infinity, but you never get there. Same thing goes to this question. Check it out. So we're starting here at the negative 4, and we're going in this direction. So again, we're starting at negative 4, which means a hard bracket, and we're going again to positive infinity, soft bracket. Done. Okay, what about the ranges? I'm not too worried about the ranges right now, but I'll just do the range for one of them. Starts at 0 and includes 0 and goes again to positive infinity. Why? Both, because this continues to go in the upwards direction. Let's just focus on the domains for a second. Let's go to this last question and let's do that one there. Aha, take a look at this. Okay, so with this particular one, we're starting at -5 here. So again, hard bracket starting at -5, and we're going in this direction to negative infinity. Soft bracket because we never get there. Okay, now, one of the things that they like to talk about in this is they like to talk about this, okay? K and infinity. So hard bracket means that's the value under the radical that you solved for. And of course, you know infinity could be positive or minus, okay? And never get there, so soft brackets. You're always going to see it in this kind of style. Now, check this out. I love this question. This question says, give me 4x minus 3 to the nearest hundredth. Find me the value of k. No problem. 4x minus 3 has to be greater than or equal to 0. Bring the 3 over, right? That becomes a positive 3. Divide by 4, divide by 4. X has got to be greater than or equal to 3 over 4. So if you think about it, 3 over 4 is just 0.75, 3/4, right? So we're starting at a hard bracket of 0.75. And we're going to go to infinity, but without graphing, let's see if we can make this happen. Let's see if we can understand this. Think about this. This is a positive value. I have not flipped this, so my value has to be greater than and equal to 0.75. All right, so my graph is probably going to be at 0.75, greater meaning going out in this direction. Oh, well, there you go. There's the arc. Oh, so I'm in fact going to a positive infinity. Well, that makes a whole lot of sense. What a great introduction to radicals. Stay tuned for a whole bunch more.